Here we go. This is my presentation for the course project. First, is there a problem? Yes. 42% of the accidents in Brazil are related to fatigue. This is a number that came from an association called Abramed here in Brazil. Can machine learning help to solve? For sure. We need integrated and large data sets, so this can be handled by machine learning. Does someone care? Yes, for sure, it can save lives. So the opportunity is to build a machine learning that predicts drivers' fatigue. And why machine learning? We would need to handle large data volumes. Real-time evaluation is for sure needed. Only machine learning can handle complex pattern recognition. We would need predictive analytics and also the learning over time that only machine learning can do. Evaluating the opportunity. So first, the target user would be the members of the company's fleet monitoring teams, because these are the people that are responsible for the driver safety. And the problem, as said before, the driver fatigue is a risk and can lead to accidents that would lead to substantial human and financial costs. And why it matters? It's gonna save lives. How they handle today? So they have fatigue detection devices that detects eye blinks, for example. They have a program for scheduled rest breaks, and they have health and wellness programs, but no machine learning. The expected impact, uh, for sure, by the end of the day, save lives, but this is a consequence for the fatigue level decrease. So the success metrics I chose to follow here is the reduction in fatigue-related accidents, and the output will be measured by using the precision recall curve. The target, I know it's very, very bold, but you would be to reduce 100% of the fatigue-related accidents. And the biggest constraint for sure is that the prediction must be delivered in real time. So identify the factors. First, the general ones. We will need the driver's ID and also date and time. The driving, lane deviations and steering wheel grip strength are uh, impacted by if the driver is tired or not, and also the health data that we would collect from the driver. First, the heart rate, eye blinking rate, head movements, blood pressure, skin temperature, stress level, and yawning frequency. Everything here changes if they are tired. So the source data, it would be not easy. A lot of device would be needed. The general data could be collected by the fleet management system, a GPS, something very simple. The driving data, we would need the advanced driver assistance systems and also sensors. To collect the health data, wearable devices and drivers monitoring systems with cameras could be very, very helpful. So first, validating the plan. What's the solution that I'm proposing here? So the proposed solution involves developing a machine learning designed to predict driver fatigue in real time, enhancing road safety and reducing the likelihood of fatigue-related accidents. And how it uses machine learning. First, the data integration. As we're going to use different devices, we need to integrate all this data. The feature engineering, machine learning algorithms will process this data to identify patterns. We're gonna use a classification model that will predict either the driver's fatigue or not in real time with real data inputs. And real-time alerts, not just for the driver but for the monitoring team. So what would be the validation plan? First, we're going to do a pilot testing. Start with a control environment where the model's prediction can be tested against pre-recorded data. And then we're going to deploy the model to a small segment of fleet under close observation. The second step would be to collect and analyze data. We're going to start adding more pilot tests and understand if the model is predicting it right. And we're going to start to validate. So we're going to conduct multiple rounds of validation to ensure that the model performs constantly across different times a day, types of routes, and drivers demographics. The fourth step is the user feedback. The user feedback is very important for us to define the UI and manage the alert system. And the last validation will be, is this scalable? So we need to test the scalability of this machine learning. Decisions of the system, the design system. First, edge AI versus cloud AI. So I chose to go with a hybrid approach because the critical real-time process needs to be handled on edge AI because of connect issues, and but the data could be periodically sent to the cloud to train and update the model. Between offline and online learning, uh, as the solution must adapt to new data frequently, I chose to go with the online learning. And between batch and online prediction, as we're gonna need to provide real-time feedback, the online prediction is needed. What are the potential risks in production? We have two big risks in production. First is the excessive latency, because for online and edge models, the low latency is very critical. And data drift. We don't know the drivers that are going to be added to this model, so the training, the data could change, and the environment could change, and we could have this could be a very big risk in production.